Hi everyone, today we will see a problem from rotational motion. So the question goes as a frictionless pulley has the shape of a uniform solid of mass m and radius r. A stone of mass m is attached to a light wire that is wrapped around the pulley and the system is released from rest, falls through a height hatch. What is the angular velocity at that moment? So there's a pulley of radius r and mass m, and around this pulley a wire is wrapped around, and the wire has a stone of mass m attached to it. Now after some time it is released and it falls through a height of height. So after some time this mass m is released and it falls through a height of height. So let's take this to be the reference line. So initially it had a potential energy of mgh. Now when it reaches the reference line, its potential energy will be converted to the kinetic energy of this small mass m and the kinetic energy of this pulley capital M. So now we have to find the angular velocity of this pulley. So let's proceed. So mgh is converted into kinetic energy of the small mass m and the rotational kinetic energy of the pulley, that is half pi omega square. And in the question it is given that it is a solid disk of mass m. So we know that the moment of inertia of a solid disk is mr square by 2 about its center of mass. Okay, so mgh will be equal to half mv square plus half mr square by 2 omega square. And we also know that v is equal to omega r, so let's substitute here. So mgh is equal to half m omega square r square plus half mr square by 2 plus omega square. Now we have to find this omega. So now let's take this omega square r square common from both the terms. So we will be having half m plus, I have taken this r square omega square common, so this there will be m by 4 and mgh. Now let's take LCM. So omega square r square uh, omega square r square will be equal to 4 2s are 8, 4 into small m plus 2m. So now mgh is equal to now I can take 2 common from both of the terms. So that will be omega square r square into 2 into 2m plus m by 8. So what I have done is I have taken 2 as common, and now I can simplify this 1 to s to 4. So mgh will be equal to omega square r square into 2m plus m by 4. This is bracket. We have to find this omega square. So now let's bring this 4 to this side. So omega square r square is equal to 4 mgh divided by m plus 2m. So what I've done is I have brought this 4 to this side and 2m plus m to the denominator. So omega square will be equal to 4 mgh divided by m plus 2m into r square. So omega will be equal to 4 mg root of 4 mgh m plus 2m r square. So m plus 2m r square. So this will be the answer for this question. It is omega is equal to root of 4 mgh by m plus 2.